Welcome back, everybody. We're going to continue with Chapter 10 today and start up a pair of sections that deal with circles. Okay, today in 10.6, we're going to look at finding arcs, circumference, arc length of circles, and then tomorrow we'll get into doing some area stuff with circles. All right, so here we go with that. All right, bunch of definitions to start off with here. Now, fortunately, you know most of these, you've seen them. Okay, we'll slow down for the new ones. Okay, first off, we're going to say a circle is a set of all points in a plane equidistant from a point called the center. So in other words, if I want to make a circle, I pick a center, I pick a distance from that center, and then the circle is made up of all the points that are that same distance away from my center. Okay, technical definition, we'll use that more as we go through. Don't really need to get too technical with the circle today, though. Okay, I'm going to say a diameter is a segment that contains the center of a circle and has both endpoints on the circle. So as in a diameter goes from one side of the circle to the other through the center, okay, all the way across. And then a radius is a segment that has one endpoint at the center and the other endpoint on the circle. So in other words, radius goes from center to side, and that gives us that a diameter is twice the length of the radius. Radius is half the diameter. Okay, all stuff you know. And then getting into the new stuff, we're going to start off with a central angle. I'm going to say that's an angle whose vertex is the center of a circle. Okay, so for example, we could say that angle APC is a central angle. This angle here is a central angle because its vertex, its beginning, is at the center of the circle. Okay, so an angle at the center of a circle. Okay, a few more definitions for you. Circumference of a circle is the measure of the outside edge of the circle. So in other words, the distance around the circle. Okay, something you've seen before. And then here's kind of the big new thing we'll start with. Arcs of a circle. I'm going to say arcs are section of the circumference. And there's going to be three types. We could have a semicircle, which is half a circle. So for example, we could say that from T around to R, here's a semicircle, makes up half a circle. And then we'll use that to divide the rest of our types of arcs. I'm going to say that minor arcs are arcs that are smaller than a semicircle. So we can say that RS is a minor arc, and then major arcs are larger than a semicircle. We could say that arc STR, all the way here, is a major arc. And that's where we're going to start today, naming arcs. Okay, so we have a circle, and problem 1, part A says, what are the minor arcs of circle C? Okay, a lot of times you'll name a circle with just the point at the center. We said minor arcs are arcs that are smaller than a semicircle. So as in AB would be a minor arc, and we'll write that as AB with a basically arc on top of it. Okay, what else do we have? Well, I could say that from B to E is less than a semicircle. So that is another minor arc. What else? We could say that AD is another circle less than half, or another arc less than half the circle. And then our last one would be DE here. Yeah, basically, when you add all the minor arcs together, you get the entire circle. All right, next we're talking about semicircles. Part B says, what are the semicircles of the circle? C. Okay, semicircle is just half the circle. So for my semicircle, if I go from A all the way around to E, I can say that's a semicircle. Now, the trick with a semicircle or anything bigger than a minor arc is I need 3 points. I've got to name that arc A, B, E. And the reason I need that B in the middle is if I just said arc AE, I wouldn't be able to tell if you're talking about the top half of the circle through B or the bottom half through D. Okay, so for semicircles, and we'll also see for major arcs, we need the 3 points. Okay, I'm not going to name all of these. There's 4 of them total, but my picture is going to turn into a mess. Another one, we could say the arc from B to D would be a semicircle. And again, I need another point to talk about which half of the circle we're on. Okay, for this one, I'm just going to name the one on the left half. Could have done the right half as well. So I'll call that arc BAD, okay, as opposed to BED, which would be the right half. Okay, again, there's a few other ones. I'm not going to name them all here. We'll move on to major arcs. Okay, for the major arcs, we said a major arc is an arc that's larger than a semicircle, so it takes up more than half the circle. So for example, if I look at the arc from A to D going around the top, so A through B through E all the way to D, I'd say that's a major arc because it takes up more than half the circle. Now when I write that, I need 3 points, so we can say A, B, D, okay, because we're running from A to D going through B. If I just said AD, I won't be sure which side of the circle we're talking about. Okay, or I could use the E, because we're also going through E, so I could say arc AED. Both of those are going to give me the same major arc. Both those are going to give me the arc that you see in blue here. Okay, so just like with angles, there's more than one way to name an arc. All right, let's do one more here. We could start at B. We could go around all the way to A. So that's going to take up more than half the circle, so we'd say it's a semicircle. And I could call that arc B. I can use either E or D. We'll just pick the E here, A. So you have to have the endpoints, but you can pick any one of those points in the middle. Again, there's a few more here. We're not going to name them all for the video. If you want to try those, you can. Okay, next thing we're going to do is actually add some measurements to those arcs. We're going to talk about arc measure. And arc measure is pretty simple. There's a few different criteria. We're going to say, let's start with a minor arc. We're going to say the measure of a minor arc is equal to the measure of its corresponding central angle. So in other words, if I'm talking about this minor arc RT here, we're just going to say it's 50 degrees because the central angle that makes up that arc is 50 degrees. Okay, we'll say the measure of a major arc is the measure of the related minor arc subtracted from 360. Okay, so in other words, if I want to know what arc R, or we'll start with a T for this one, TQR is, that'll just be 360 minus this 50. That'll give me this other central angle. Okay, so again, with arc measures, we're talking angles. Last thing, the measure of a semicircle is just 180. Okay, half the circle is 180. That's a little trick we can use there. And then one more thing real quick. We're going to talk about adjacent arcs. Those are just arcs of the same circle that have exactly 1 point in common. So in other words, arcs that are next to each other, a lot like adjacent angles. We could say that AB and BC are adjacent arcs. And then with that, we have the arc addition postulate. Okay, just like the segment addition postulate or the angle addition postulate, it just means that I can add arcs together, add their measures together. So if I want to know the measure of arc ABC, the arc that goes from A through B to C, I could just add arcs AB and BC together. That would give me that total. Again, really, since arc measure are coming from central angles, just like we can add angle measures together, we can also add arc measures together. Let's go ahead and do that in problem 2 here. Okay, it asks, what's the measure of each arc in circle O? First thing we have is arc TU. And that's easy. I have the central angle that makes up TU, which is 60 degrees here. So I just say that arc measure is just 60 degrees. Next up, we want to know the measure of arc SU. Okay, let's find SU on our picture. Okay, so SU goes from S through T to U. Still a minor arc. That's why I can name it with 2 letters instead of 3. And basically what that's going to be made up of is my 2 different angles here. That's my arc addition postulate. it's going to be 20 degrees plus 60 degrees. In other words, 80 degrees. Okay, so just like if I said, what's the measure of angle SOU, I'd add these two measures together. Same thing with the arcs. Okay, next up, arc RST. Let's find that. R through S to T. Okay, well, that looks like it's just a semicircle. It's making up half the circle. And I can tell that because I have a straight line through R, through O, through T. Okay, we know that semicircles are just 180, half of 360. So we'll say that arc measure is just 180. Okay, last thing, arc RS. So from R to S. Now I don't know this measure here, but just like we've been doing all year long finding angles, I can do some subtraction. I'm going to say RS is the semicircle measure, 180, minus the 20, which will give us 160 degrees. Okay, we have a linear pair here. We have supplementary angles, whatever you want to call it. Okay, but to make the 180, we need 160. That's why it's 160 for that one. Moving on, we'll come back to arcs in a few minutes, but next thing I want to talk about is finding the circumference of a circle. Okay, circumference again is just the distance around the circle. And the formula we have for that, there's actually two of them. They mean the same thing, but we could say circumference is equal to d times pi, so pi times diameter. Or circumference is 2 pi r, in other words, two radiuses, which give us the diameter. And we can use either one of those depending on whether we know the radius or the diameter of the circle. All right, now you've seen circumference before, so let's jump right into an applied problem, do a complicated one. Problem 3 says, a merry-go-round has seats that are 7 feet from the center of a ride and 10 feet from the center. How much further does a child seated on the outside loop travel than a child seated on the inside loop in one complete revolution? Okay, so what do we have going on here? We've got the center of a merry-go-round, and we have 2 rows of seats. One row that are 7 feet from the center. Okay, that's the inner row. And another row that is 10 feet from the center. And that's how most merry-go-rounds I've seen look. And we want to figure out how much further does a child sitting on the outside travel in one revolution as opposed to a child sitting on the inside. Okay, because since the outer is a bigger circle, that child needs to go farther. So in other words, I want to know the difference between the circumferences of these two circles. Okay, we just said that circumference is equal to 2 pi r, 2 times pi times the radius. And I'll use radius because I get the radius here. I could double that and use the pi times d, but we'll just use radius here. And basically the way this problem is going to work is we'll take the circumference of the big circle and subtract it from the circumference of the small circle. Okay, for the big circle, I've got 2 times pi times 10. Okay, because 10 is its radius, that's going to give me the circumference around that larger circle. And it'll subtract for the smaller circle 2 times pi times 7. Smaller circle has a radius of 7. And that formula is going to give us the distance around that smaller circle here. Okay, how can I rewrite that? Well, for now, I'm just going to rewrite that as I'm going to multiply the numbers through. 2 times 10 is 20. So I'm going to say I have a 20 pi. Okay, minus 2 times 7 is 14. And we get a 14 pi. And what I'm doing here is I'm leaving these answers in terms of pi. Okay, rather than multiplying through by the 3.14 blah, blah, blah ugly number and getting some ugly numbers to work with, I'm going to leave things in terms of pi here to make my calculation easier. Okay, because 20 pi minus 14 pi is just the same as 20 minus 14, which is 6. So I could say that's 6 pi. Okay, again, that's a lot easier calculation than actually multiplying that pi through. And now this problem doesn't specify if it wants the answer in terms of pi or rounded. If it said in terms of pi, we just leave it the way it is. But typically with a real world problem, you'll plug that in at the end. Okay, 6 times pi would be what you plug into the calculator. That gives me an 18.8. And what are we talking? Feet. All right, so we'll say that's my answer. Again, typically you will plug in the pi and round on real world problems, but on MathXL you will see somewhere it says leave it in terms of pi. If it does, that's what you're looking for, just the number times pi. Don't actually use the pi on the calculator. All right, let's finish up by putting all that stuff together here. Okay, both our arc measure and our circumference to talk about something called arc length. I'm going to say arc length is a fraction of a circle's circumference. Okay, so if I have arc AB here, the measure of the arc is this angle. Okay, it's the angle, the central angle. The arc length is actually going to be the distance from A to B along the circle. It's going to be part of the circumference. Okay, to calculate that, I have two kind of ugly looking formulas, but they're actually pretty simple. Basically what we're going to do is we're going to find the circumference of the circle, 2 pi r, and then multiply that by the fraction of the circle, so the arc measure divided by 360. So this will give us a fraction of the circle's whole circumference. I could also write that as just pi times d for the circle's circumference. Instead of 2 pi r, we could just say pi times d. Again, we just have circumference times fraction. Okay, either way, that's going to give us the arc length. So let's look at finding the arc measure in problem 4. And for part A, we'll look at arc CD. So again, that is the distance along the circle from C to D. Okay, it is a fraction of the circumference. And the formula for that we just gave, I'm going to write a little different here, but I'm going to say the measure of the arc divided by 360. Okay, that'll give us the fraction of the circle we're looking at. And then times, since I have the diameter here, I'll say pi times d. Let's fill that in. Measure the arc. Okay, I've got a 90-degree angle here, so we'll say 90 degrees. Over 360. Okay, times pi times the diameter, my 9. All right, and I'm just going to leave this one in terms of pi. What I'll do for that is I'll go 90 divided by 360 times 9. That gives me a 2.25. And then again, instead of writing out the pi, we'll just, instead of plugging the pi into the calculator, we'll just say pi at the end, we'll write it out. So in terms of pi, we could say this is 2.25 pi centimeters. Now, if I wanted to round that, I'd multiply by the pi. If the question said, what's the answer to the nearest tenth of a centimeter, we can multiply that out. Okay, so arc length is actually pretty simple. It's just the circumference times a fraction. And I guess you don't need to do this, but if we reduce this fraction, we'd end up with a fourth. 9 divided by 360 to fourth. So in other words, what we're doing here is we're just taking a fourth of the circle's whole circumference. All right, part B is the same idea. I believe there's 2 questions in that. Why don't you take a minute, pause the video, work those out, and then hit play to check your answer or to get some help if you need it. All right, let's go through these quick. 2 arc lengths we want to find, SR and STR. Okay, again, our formula was measure of the arc divided by 360, and then just times the circumference of the circle. I'll use the 2 pi r for this one because I know the radius instead of the diameter. All right, so for SR, filling that in, SR is this arc. with an arc measure of 120. So we'll go 120 over 360 times 2 times pi times 4 the radius. And when I multiply things through, leaving the pi out of it, I get a 2.6 repeating. So we could say 2.6 repeating pi. All right, then same idea for the larger arc, the major arc, arc STR. That's going to be talking about this chunk of the circle. And first thing I need to know for that is what my arc measure is. In other words, what this angle is. Okay, to get that, what I can do is I can take the whole circle, 360, minus the part I'm not including, the 120. Okay, and that's equal to 240 degrees. Okay, so that's my arc measure. So now I can go 240 over 360, and then times the same circumference, 2 times pi times 4. Now when I multiply that through, I end up with a 5.3 repeating. So we could say 5.3 repeating pi. All right, now trick with this one, if I added the two of these together, I should get the whole circumference. Okay, so here's an example of finding a few different parts of that circumference, a few different arc lengths. All right, there you go. That's it for section 10.6. We kind of talked about a lot of different stuff today, but it kind of all goes together, so it's really not that much. As you do the homework, I think you're going to say, hey, this stuff isn't too bad. Okay, so give the homework a shot, work through this stuff, and like usual, if you need help, if you get stuck with something, make sure you're getting help, make sure you're asking for help.